Hi, in this video we will solve problem number 4 of our additional list of Matlab exercises. Here we have to plot the profile of a 2D heart, and we will do so by first coding two functions, the first one called heart upper and the second one heart lower, that plots the upper part and the lower part of a heart respectively. And then in the second part, we have to write a Matlab script that creates a one-dimensional vector between -2 and 2 using 1000 points, and that calls these two functions and plots them. Okay, so we will start by calling Matlab and setting our default directory. That's it. Let me say in desktop, I create a new folder called problem 4 and I set it as my default directory. And then I propose to start by writing the two functions. Okay, so we will open a new script, and then we will first write the corresponding part to the upper part of the heart. So I copy that, Command C, I go there and I start by the sentence function, which must be the first sentence of any Matlab function, and the input parameter is a vector x, and the output parameter will be a vector y containing the profile of the y values of the upper part of the heart. So this function is really very short. It's y equals, and then will be the square root, okay, of the absolute value of x minus 1. Sorry, let me check that. It's 1 minus the absolute value of x minus 1 to the square, right? So this is absolute value of 1 minus the absolute value, that should use here a parenthesis and close it here, is the absolute value of x minus 1, all of them to the power of 2. And here is the key point in this function. So x is a vector, the absolute value of x is a vector minus a constant, then we get a vector, and we want to compute the square of each component of the vector. So we should use dot, and we have to use this operator in order to compute the square of each component of vector abs of x. So this is the first function. We save it. Okay. And then we will create the second part, or the second function, which is y heart of lower of x. So we start again. The first sentence should be function in order to set that this is a function. Okay, and now this function is a little bit more complicated, but then it's the same. Okay, so y will be equals to, I think it's minus 3 times the square root, and inside the square root, let me check that, the square root of 1 minus the square root of absolute of x divided by 2. So this will be 1 minus the square root, again, the square root of the absolute value of x divided by 2. Okay, so then I add the semicolon here. So here we have, and I save it. So this will be lower. Okay, so these are the two functions. Y equals minus 3 times the square root of 1 minus the square root of absolute of x divided by 2. So it's an example of how a function can call another function. Okay, and the same for the upper part. It's 1 minus the absolute value of x minus 1, all them to the square. Okay, so now we have to create the main script, and I think it will be simple. The first two sentences always will be clear and CLC to clear the memory MATLAB workspace and the command window. Then we will use a linspace to create a discretization using 1000 points from -2 to 2. Okay, so we can say x ini equals -2. We can say xn equals 2. Okay, do not forget the semicolon, please. And then the number of components, numcomp, for instance, that will be 1000. Okay, so then we create the discretization x equal linspace. Okay, so that's the linspace. Sorry, and now we need three arguments. The first one is the initial point of the vector. The second one is the last point of the vector. It's xn. And the third is the number of components. Okay, so this is the vector, and now we have to compute the upper part and the lower part of the heart, calling the two functions. So let's say y up will be equals heart upper of x, semicolon, then Command C, I copy this here. I can use, for instance, I low equals, that will be heart lower of x, right? So here we have the y components of the heart profile, and finally we will plot these results. So I create a figure, that will be, for instance, figure 1. I clear the figure, CLF, and then I plot these results. So that will be x, y up. Okay, and now I will specify the color that I will use for plotting the function. So I think that they do not say anything about how to plot, which color use to plot the heart. So we will use, for instance, blue for the upper part. Then we will say a hold on, and then we will plot the lower part, which is x, y low, using, for instance, the continuous line in red color. Okay, so here we go. The initial value is -2, the end value is 2. We use 1000 points. We create the vector. We call the two functions, heart upper and heart lower, to create the two vectors, y up and y low, and we plot them. So let's try to run the code. We have to assign a name, so that will be problem 4. And we get I forgot here an A, linspace, right? And we should get the plot here. Nice. Okay, that's all. See you soon. Bye-bye.